Hello everyone, my name is Nash Kuney, and in this video I'm going to be talking about carbon fiber, what it is, where you can find it, and how it's made. So what is carbon fiber? So carbon fiber is a relatively new material, and when I say relatively new, I just say that because even though it was around when Thomas Edison was alive, it has not been embraced until recently. So it's a modern material, which is where I get the wording of relatively new, and it's made through a carbon weave, as you can see on the screen here, and it is just strands of carbon that are woven together much like a basket to create more or less a fabric that will be applied to parts, and it's known for being very strong and very lightweight, and you can find it in industries such as the automotive industry, where you'll see car parts and whatnot, and you'll see it in aerospace industry, which is really known for its high heat tolerance, and you'll also see it in sporting goods such as hockey sticks and golf clubs with the shafts and whatnot, because it makes things lighter weight and it's very strong, known for its high performance. So how is it made? So carbon fiber is made through certain materials that are arranged into strands or fibers, if you will, and they are heated to very high temps without oxygen. Now, not having oxygen is very important, because if oxygen were present, then the strands would just burn, and then you wouldn't have any material to compose the carbon fiber. And so the high temps are to expel most of the non-carbon atoms. And this gives you an almost pure carbon content material. So once you have all the strands or the fibers, you will weave them together, and then the surface has to be oxidized. And the reason for that is for the next step, which is the epoxy application. So carbon fiber itself is just more or less a fabric, and the epoxy actually forms it and makes it a usable piece. And without the surface oxidization, the epoxy wouldn't stick. So it's much like when you sand wood before you paint it, so that way the paint will stick and last. So for an example, as I mentioned earlier with the automotive scene, these are two very similar hoods for specifically Nissan 350Zs. And if you look at the top one, it is a Seabond brand carbon fiber hood for just over $2,000. And on the bottom, there's a Carbon Creations brand carbon fiber hood for about $600. So now you're probably wondering, what's with that large of a price gap? And well, that's very simple. So the Seabond carbon fiber hood will have a lot more time spent in R&D to make the product fit the car better and perform better. So the cheaper hoods, they still have all the carbon fiber properties. They're still strong. They're still lighter weight than a stock replacement part, but they're not going to fit as well first try. They're going to need more modifications, and they're probably still going to be heavier than the more expensive counterparts, just because of the processes and whatnot that make parts. So in this case, you really get what you pay for, and the more expensive parts are going to not only fit better, but they're going to perform better on a scale comparing them to the cheaper parts. So if I were to compare carbon fiber to another material, I'd say it's very similar to aluminum, because it is still on the spectrum of steel, but it's lighter weight. So if you take these two drive shafts, which go underneath cars for rear-wheel drive cars and all-wheel drive cars, and it's what takes the power from the transmission to the rear end to spin your wheels. So comparing to steel drive shafts, aluminum drive shafts are about 10 to 20 pounds lighter than the steel counterparts, which gives you less rotational force necessary to spin the wheels. So that gives you faster revs, and it is less weight to spin. But the downside to aluminum drive shafts is, upon failure, aluminum will shatter, which is a lot more catastrophic than a carbon fiber counterpart. Now, even though the aluminum drive shafts are a lot cheaper, the carbon fiber are a lot better way to go, as long as you're going for high horsepower situations. Although the carbon fiber counterparts are only 1 to 2 pounds lighter than the aluminum ones, so it's pretty comparable in a weight sense. The carbon fiber does absorb vibrations and other things on that spectrum better than the aluminum. The aluminum can be a bit more clunky. So the carbon fiber will allow for the faster revs like the aluminum, but it will be a lot smoother. And a benefit to the carbon fiber is upon failure, it will actually shear instead of shatter. So some specs on carbon fiber. The modulus of elasticity, or the Young's modulus, is about how much your material can stretch or compress before it starts plastically deforming and staying the way it has been strained to. So the modulus elasticity is 70 gigapascals around, because carbon fiber is very specific to how it's made and who makes it. So there's no real hard numbers on its performance. But 70 gigapascals is relatively high. And if we look down at the shear modulus, the 33 gigapascals, that's also high for materials like it. And then now if we look down at yield strength and tensile strength, at 470 megapascals and 700 megapascals respectively, these numbers are very comparable to steel. So that's something that reinforces carbon fiber having the strength of steel. But then if we go down to density being about 2.26 grams per centimeter cubed, that is a quarter of the density of steel, which with the yield strength and the tensile strength, you're getting the strength of steel, but the density is so much less than steel, giving you the lighter weight abilities. Now, the big kicker for that is if you jump down to price per kilogram, carbon fiber can run over $22 per kilogram, and you can buy steel in bulk for under $1 per kilogram. So that's the big kicker. But the melting temperature is over double the melting temperature of steel, which makes it fantastic for high temperature applications. And the radius of atoms comes in just under 70 picometers, which means you can fit a lot of atoms within one strand for carbon fiber. Now, recycling carbon fiber is a little touchy. It can be kind of complicated, which means it can get expensive, but probably the easiest way to recycle carbon fiber is to take the parts, grind them up into smaller pieces, as you see in these two piles here. And if you look at the pile on the right, that's before you would recycle it. So similar to how you would treat materials to make carbon fiber, you basically make it over again. So you heat it up without oxygen to burn off all the epoxy and all the other materials that are with it to just get the pure carbon back in the strands, which is what you see in the left pile. And that makes it to where you can apply it to new products and such to make it a new product all over again and fully recycle the material. So that's a little bit about carbon fiber. I hope you learned something. Thanks for watching.